So this second to final slide for chapter 8 summarizes how to determine the polarity or the uneven distribution of charge that may be present in a molecule due to its geometry and its composition. And we basically said that if a molecule will be nonpolar if all of the bonds are nonpolar or all of the atoms attached to the central atom are the same. And if there are no lone pairs of electrons on the central atom. Anything else, if you have lone pairs of electrons on the central atom, and if the outer atoms are different that are attached to the central atom, then your molecule will be polar. So there are two exceptions to where you have a central atom that has lone pairs of electrons, but it is nonpolar, and it has to do with the molecular geometries and electron geometries as shown below. I'm not going to test you on those. I just want you to be aware of them for when you do your online homework. So this is an important slide to maybe have next to you when you do your online homework. But using the qualifications that were listed up here and in the previous slide and videos about determining polarity, let's go ahead and finish our conversation on chapter 8 by determining the polarity of these two molecules, carbon dioxide and NH3. And so how to determine the polarity? It all starts with, the Lewis dot structure. So let's go ahead and do those two. Get my little pen. So look at our periodic table, and we see that carbon's in group 4, so we've got to add 4 to 2 oxygens. Oxygen's in group 6, so each contributes 6 valence electrons, multiply by 2. And we've got 16 valence electrons that we use for our Lewis dot structure. Carbon is least electrolyte negative, so it is going to be the central atom. Scatter my outer atoms around it. Start to distribute my electrons, my valence electrons, by first doing single bonds. 2, 4. I've used 4 of my 16 valence electrons. Now I'm going to do my octets on the outer atoms first. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have now used all 16 of my 16 valence electrons. And I see that my oxygens are happy, but carbon is not. So carbon needs to look to see if it can share any lone pairs of electrons, and we see that each oxygen has some. We can share a lone pair from one oxygen to form a double bond, as well as the others, to give a Lewis dot structure as such. Now, if you want to draw resonance structures for this molecule as well, you can, but for this we're just determining the polarity, so we just need to look at one resonance form of the Lewis dot structure. Looking at that molecule, okay, so we've got the Lewis dot structure. Now I need to know the VSEPR notation and shape to help determine the polarity. Well, I see that my VSEPR notation is AX2, which is linear. And according to the rule that we stated previously, if your central atom is attached to outer atoms that are all the same, which it is, and there's no lone pairs of electrons on the central atom, so that means carbon dioxide is nonpolar. So that is a nonpolar molecule. Now let's do NH3. Start with good old Lewis dot structure. Nitrogen is in group 5. Hydrogen, group 1, multiplied by 3. So I have a total of 8 valence electrons. Hydrogen cannot be the central atom. Hydrogen's always terminal, so nitrogen's got to be the central atom. Scatter my outer atoms around it. Start to distribute my valence electrons by doing single bonds first. 2, 4, 6. I've used 6 of my 8 valence electrons. Complete octets on outer atoms. Well, that's hydrogen. It wants a duet, so it's happy. But I have 2 more electrons that I need to place. Any extra electrons go on the central atom. In this case, nitrogen. 7, 8. So that is my Lewis dot structure for NH3. Its VSEPR notation, considering nitrogen as the central atom, is AX3E. And while X, hydrogen, is all the same outer atom, I see that lone pair of electrons on the central atom. That lone pair of electrons changes the overall charge distribution of that molecule. So due to that lone pair of electrons on the central atom, this molecule NH3 is polar. So that is the process that you should go through to determine polarity of molecules. And we'll do more examples in class, but that is the end of my online videos for Chapter 8.